Okay, what we're going to take a look at next is contour mill. And if we look at this, we have a contour mill that wants to go around the part, and we're currently using a 5/1000 end mill. And so we want to make a change to that just because we want to adjust how the contour is going to work. And this would be similar to if we had a rough mill, which we'll take a look at here in a little bit. Contour mills are considered finish mills or finish passes. Rough mills are just roughing. It just blanks it out and leaves some stock generally. So we're going to edit this contour mill and just take a look at it so we can understand a little bit more about it. Again, like before, right click and select edit definition, or double click on the feature to get the dialog box to open. Okay, with the dialog box open, what we're going to do is we're going to start by looking at the tool. And one of the cool things about this is when you go to a tool and I come out here on the screen, you can actually see what it's going to look like. Now, the 5/1000 end mill is probably not the best tool for this scenario, so we're going to pick a tool that's a little bit bigger. And where we do that is we go to our tool crib, and then we have the ability to interrogate or select any of the tools in our tree. Now again, this is standard tooling by default, and what we're going to do is we're going to select, we're just going to try a 3/8 end mill 4 flute. So if I come down here, you can see I get a preview of what it's going to look like. I get all the diameters and dimensions that go with it, and where those numbers end up are right here. So you can see you have radius, tip, high-speed steel. If you wanted a carbide 3/8, I can select the carbide, which is CRB. Once I have this row selected, I'll just hit select, and it's going to ask if I want to update the holder also. So if I'm using collets, of course I want to update it because the shank is from 5/1000 to 3/8. So we'll just hit yes. And now we have a 3/8 tool. So if I hover out here on the screen, I have a tool that follows my mouse and pointer around. And what this allows me to do is if I look at the CamWorks viewports, I have the ability to come in and look and see if I use a 3/8 end mill, how am I going to finish that radius? Well, it looks like it may not finish quite right, so 3/8 may be a little too big for me. So we'll go back to the tool crib, and we're going to select a 1/4 inch carbide. So we'll just highlight that, hit select, update the holder, and now if I come and look at it, you can see that's a better fit for finishing around my part. I use this a lot when I'm working with tight tolerances and machining to understand how the tool paths are going to be affected based on the tool that I pick. And it's really nice because all of the interaction and zoom in, zoom out is just standard SolidWorks. So with the 1/4 inch tool there, we're going to go ahead and go to our feeds and speeds. And again, these feeds and speeds look very similar to the drill. The one thing that you will notice is different is the Z feed rate and the lead-in feed rate. Now, let's say I want 5/1000 per tooth, and then I want the spindle speed to be 6,500. If I type in 6,500 correct, you'll see that with 5/1000 per tooth on the carbide end mill we have, which is a 4 flute, it's going to take the 4 flutes times 5/1000 per flute per revolution and then give us 130 inches a minute. Now, what a lot of people get into here is they don't really look at the Z feed rate or the lead-in feed rate. And this sometimes gets people into trouble because this is how fast the machine is going to feed into the part once it goes to feed mode. Now, you may not want to take a full feed-in rate into your part if you're doing plunging. So one of the things you can do here is you can say, well, I want to feed into the part in Z at 50% of my XY feed rate. And this gives me a slow entry into the part. And then you may also want to say, well, when I start cutting, I want to start at 25%. So that way it'll come down, it'll feed in at 50%, and then before it just takes off at 130, it'll actually start cutting and create that path at 25%. And again, when we talk to the technology database, this is all stuff that we'll come up with later, but I just wanted to show that because a lot of new beginners with CamWorks, they ignore these two rows here, and once they ignore them, they can't figure out why the part why the end mill jams into the part, and they end up trying to edit the feeds at the machine, when really all it is just changing these numbers here. And you do have the ability to check or uncheck if you don't want 50%, but you know an actual number of inches per minute you want to run. Like let's say I want it to be 25 inches a minute. You can just type it in there and ignore the percentages.